Well, good day. Here we are doing a bit of mathematical literacy, and we are tackling the topic that I enjoy the most, and that's the topic on space, shape, and measurement. There are three areas we're looking at. We're looking at the perimeter, we're looking at area, and we're looking at volume. And what we're going to do now is we're going to spend a bit of time looking at some of the questions that were found in the 2010 November paper. We're going to look at paper 1 first of all. So we're going to look at questions which are relatively straightforward, but have some good basic principles. And once we've mastered those, we are then going to go on and look at some questions from paper 2, which require a little more thought and a little more understanding. But once you've understood the basics, I'm sure we'll be fine with it. So, space, shape, and measurement. Let's have a look at the very first question, which came up in November 2010, paper 1. It was actually question 1.3, but I'm going to call this question 1. Now, during an experiment, an amount of liquid was poured into a calibrated rectangular container as shown in the diagram below. Now, I know exactly what you're asking yourself. You're asking yourself, myself, what does the word calibrated mean? Well, the examiner was extremely nice, and he actually tells you what calibrated means in the very next sentence. Let's have a look at this. It says here, a calibrated container has accurate measurements marked on it. It is used to measure volume. So if we were to look at this picture or diagram that's given to us, you can see that we do have a rectangular prism. Okay, so the bottom is a rectangle, and it also has a height. And on this whole shape, we have little markings. And these markings are telling us the volume. Now, volume is, when we work with units in volume, we work with cubed. So if you look at our diagram, it says quite clearly 1,000, 2,000, 3,000, 4,000 centimeters cubed. Let's go on. What's the examiner going to ask us? He's going to ask us the following. Calculate the volume in centimeters cubed, and that's important to remember, please. Okay, centimeters cubed. So once we've finalized our answer, we're going to say, is it in centimeters cubed? It has to be. That's what the examiner's asked for. And if we don't do it, he's going to take a mark away. Now, so calculate the volume in centimeters cubed of the container. Use the following formula. Volume equals length times breadth times height. You're going to hear me say this 1,000 more times today. In this whole section, and this is why I love this section, in this entire section on space, shape, and measurement, they always give you the formula that you need to use. And folk, if you don't use the formula, you're making a huge mistake. Here's another little hint. If you make up your own formula, you're also making a huge mistake. So only use the formula that's given to you and make sure you use it. Another little thing I want to just bring your attention to is the following. I always tell my students, a question is not a question unless there's a mark allocation. If the mark allocation is not there, you have no idea on the amount of work that's required to ask that question. So in this question, calculate the volume, you will see that there are 2 marks for this question. In other words, folk, there's not a lot of work involved with this. My answer is not going to be a page long or even half a page long. It's probably just going to be 2 or 3 little lines. So, calculate the volume. First thing, we're going to use the formula that's given to us. So I'm going to write volume equals my length times my breadth times my height. Now, what is the length? What is the breadth? What is the height? Well, let's have a look at the question. It says there, there it is right there. The length is 50 centimeters. So I'm just going to write 50 centimeters times the breadth. The breadth is 40 centimeters times 40 centimeters. And the height of my container is 45 centimeters. There it is. So now what we're going to do is we're going to zip up our calculator, and I'm going to say 50 multiplied by 40 multiplied by, and my height was 45 centimeters. And my answer then is 90,000. So 90,000 is my answer. Yes? No? No, it's not. I haven't finished answering the question. The question said in centimeters cubed. So what is it? It's 90,000 centimeters cubed. Folk, 2 marks. Where are those marks going to come from? First of all, 1 mark is going to be given for substituting the 50, the 40, and the 45. And the other mark is going to come from the actual answer of 90,000 centimeters cubed. Simple? Of course it is. It's straightforward. Let's look at the next one. 1.2. 3,000 centimeters cubed of the liquid was poured into the calibrated container. Calculate the height of the liquid in the container by using the following formula. So in other words, now what they're saying is this. They are now telling us that there's so much liquid poured into this container. We don't know how high it is. So if I were to show you this glass of water, I would say to you, I've got an amount of water in here. How high is this come to? Okay? What height does the water reach on this glass? So let's have a look at it. So the question was, we've got 3,000 centimeters cubed of water. So in this container, there's 3,000 centimeters cubed of water. There it is there. And we want to know, well, how high is that? Again, our examiner, wonderful person, gives us the formula. Tells us height equals volume divided by the length times the breadth. So looking at that, you write the formula, height equals volume divided by length times the breadth, and away we go. What was our volume? It was 3,000 centimeters cubed divided by, what is the length? Now, please understand, folk, that even though we're changing the amount of liquid in the container, the height differs with the amount of liquid, but the length of the container remains the same. The breadth of the container remains the same. So we're going to get the length and the breadth from here. The length is 50, the breadth is 40. Okay? That can't change. We can't suddenly squash up the box. It's still there. So 50 and 40. So my length, 50 centimeters. My breadth, 40 centimeters. Equals 3,000 centimeters cubed divided by 50 times 40 on our calculator. Let's go. 50 multiplied by 40 equals, and there we get 2,000. So I'm going to say 2,000 centimeters. Now, I want you to take notes of something. We've got centimeters times centimeters, which is centimeters squared. Now I'm going to divide 3,000 by 2,000. So again, our calculator, we're going to say 3,000 divided by my 2,000. And I get 1.5. So equals 1.5. 1.5 what? 1.5 centimeters. Height is like a length, isn't it? The height is 1.5 centimeters. You can't have a height of 1.5 centimeters squared or 1.5 centimeters cubed. Height is just a length. So it's only centimeters. So the height, 1.5 centimeters. Folk, again, let's have a look at the mark allocation. You were given 2 marks for that question. I would say the 1 mark is for putting in the correct values, and the other mark is for that final answer of 1.5 centimeters. So that was question number 1. Now, let's have a look at question 2. Question 2. Tandiwe wants to make a new pencil holder. She has a choice of an open cylindrical holder or an open rectangular holder. She wants to cover the outside of the holder to match the tablecloth on her desk. So here's our containers. We have a cylinder. There it is. It has a radius of 5 centimeters. Now, let's stop there for a minute, because this is an important fact. What is the difference between a radius and the diameter? So if we were to look at the circle, and I'm going to just draw it here quickly. If I were to give you a circle, and it's a funny looking circle, but you get the idea. My diameter is from, if that's the center of the circle, my diameter is from the one side of the circle to the other, going through the center. Now that really looks wrong. And my radius is from the center of the circle just to the circumference of the circle. And it takes two radiuses to make one whole diameter. So I have a radius, and those two radiuses make the diameter. Got that? So let's have a look here. My holder, radius 5 centimeters. In other words, from the center to the circumference of 5 centimeters. And the height is 15. So from the top to the bottom, we have a height of 15 centimeters. Now, the rectangular holder has a length of 10 centimeters. So this length here, 10 centimeters. The breadth is 8 centimeters, and the height, 15 centimeters. Determine the surface area of the cylindrical holder. Okay? So we are now going to try and find what is the surface area of that holder. So here we have a little girl who wants to make herself a pencil holder. It must be the same color as her tablecloth. So she gets a little bit of extra material and she wraps the material around her little holder. And she wants to know, if I take the round holder, the cylinder, how much material am I going to use? If I take a square little box, how much material am I going to use? And that's what we're trying to calculate for her. Now, again, lovely fact here, we are given the formula. So let's go for it. And we're going to do 2.1 over here. So to calculate the surface area, formula given to us, got to use it. 2.1. The surface area, 2 times pi times the radius times the height. Now, I know all these things. 2 is 2 times pi. Now, folks, if you look at your calculator, you will see that there's actually a pi button on that calculator. Can you see that? Here it is over here. Okay? But in this question, it clearly states we may not use that button. In fact, we have got to use 3,14. So I'm going to say 3,14. So 2 times 3.14 times my radius. What was the radius? Let's remember, 5 centimeters. So times 5 centimeters times the height. How high was my container? It was 15 centimeters. So 15 centimeters. Okay? Now, straight to our calculator. We are going to say 2 multiplied by 3.14 multiplied by my radius was 5 times the height was 15 equals, and there it is, 471. 471. 471 what? 471 centimeters squared. Why squared? Because we're working in area. Happy? Straightforward, isn't it? Well, it is if you follow the basic rules. 2 rules here. Number 1, use the formula given. Number 2, because you're dealing in area, we end with centimeters squared. Right, now let's look at 2.2. 2.2, and I'm just going to get rid of all this so I can write it underneath here as well, In question 2.2, we're going to find the area of the rectangular holder. Now, to find the area of the rectangular holder, we are given the formula, and we're told that the area is equal to 2 times the length plus the breadth times my height. See how I'm using the formula? Just as they tell me to use it, so I must use it. 2 multiplied by, let's go back to our diagram. Here it is. My length is 10, my breadth is 8. So it's 10 plus 8 times, what is my height? My height is 15 centimeters times 15 centimeters. 2 times 10 plus 8, we know is 18, times 15. On my calculator then, we're going to say I have 2 multiplied by 18 multiplied by 15 equals, and I get an answer of 540. Let's just extend that a little bit. 540. 540 what? 540 centimeters squared. Why squared? Because we're dealing in area. There we go. Our very first 2 questions from paper 1 last year. Straightforward, basic, but they're basic because we followed 2 rules. We've used the formula applied, and we've ended in the correct units. Right, now let's have a look at question 3. Now, what I want to say about this question before we even begin, it does come from your November 2010. It does come from paper 1. But what I have done is I've taken the question and I've extended it a little bit. So what I've said is that this is a great question, but you know what? If the examiner had more marks and if the paper was a little bit longer, perhaps he could have taken the question further and asked a little bit more. And you'll see what I mean by that just now. Let's have a look. Question 3. Mrs. Smith and her touring party decide to visit an indoor swimming pool. Okay? So it seems that Mrs. Smith is a tour leader and she takes a group of people, and these group of people say, ma'am, we want to go swimming. So she takes them off to a swimming pool. Now, the kiddies pool at the indoor pool has a diameter of 5 meters. There is a protective fence, 3 meters, around the outside of the perimeter of the pool, as shown in the diagram below. Now, this is where I just need to stop for a minute, because what actually happened in your November 2010 paper, the examiner made the question to seem like the fence was right on the pool itself. And in real life, that doesn't really happen, does it? Normally, there's a little patch of grass or a little patch of cement or slasto or something around the pool before the fence. So I've just changed the question a little bit, made it a little more meaningful, and made it a little more difficult. Okay? But you're going to manage it fine. Let's have a look. So what we've actually got now is we've got this pool. It has a diameter of 5 meters. And remember what we said before. Radius is from the middle of the pool to the circumference. Diameter is from the one side of the pool to the other side of the pool, going through the middle of that pool. Great. So we have a diameter of 5 meters, and we've got an area 3 meters wide all the way around the pool. And then we have this fence going around that area. So the first question says this: determine the perimeter of the fence. So we are wanting to know how long is the fence that's going around this whole pool, as well as the cemented area or the grassed area or whatever this area actually is. Okay, so if we were to pretend that this was all grass, we want to know what is the perimeter of the fence. Again, use the formula. Got to use the formula. Perimeter equals, so let's go. Perimeter equals pi times the diameter. Okay? So pi, again, we have to use 3,14. Why? Because the examiner tells us to, and we've got to listen to this guy. And then the diameter. So now, what are we actually wanting here? We are wanting the diameter, and let's look carefully. I'm going to get rid of all this green here so we don't get confused. we are wanting to find the diameter from the one side of the fence right through to the other. Now we know this length in the pool is 5. So this is 5. What is this length here? Hey, that's 3. What is this length? It is also 3 meters. So what's the diameter from the one side of the fence to the other? We have 3 meters plus the 5 meters plus the 3 meters. That makes 11 meters. So going back down here, times 11 meters equals, up comes our calculator, and we say 3.14 multiplied by 11 equals, and there we get our answer of 34 and 27 over 50. Now I'm going to change that to a decimal, so let's get that on our calculator. We're just going to change it quickly, and there it is, 34,54. 34,54 meters. And perimeter is a length, isn't it? Because it's a length, I'm going around. So it's just meters, not meters squared, not meters cubed. Squared belongs to area, cube belongs to volume. So it's just meters, 34,5 meters. Are we happy with that? Let's look at the next question. So the next question goes on. Now, this is the question that I've really changed, but it's something that I feel an examiner could easily ask you. It's a wonderful question, and I'm going to take it a little bit further. So the area between the pool and the fence needs to be grassed. Okay? Grass is bought in trays which can cover 4 meters squared, and each tray cost 89 Rand 95 cents. Determine how much it'll cost to grass the required area. Area of a circle is pi times r squared, and we got to use pi as 3,14. So we're asked, calculate the area of this whole section here. We got the pool, we got the fence, and your task is go out there and buy some grass. And grass the area between the pool and the fence. How much is this grass going to cost us though? And that's what we've got to calculate. So having a look at it, first thing, we need to calculate how much area I'm going to have to plant some grass in. That's task number 1. Now how on earth are we going to do that? Well, let's have a look. It is possible for me to calculate the area of just the pool, and it's possible for me to calculate the area of this whole area, the whole fenced area, including the pool. So just the grass, I could take the whole area minus the pool, and I'm left with the grassed area. Do you understand that? So let's go for it. Firstly, it says quite clearly again, use the formulas. So I'm going to say now, the area of the whole pool, okay, is going to be pi, which is 3,14, times, now, what is the radius of this whole area? Do you remember earlier, we said that the distance from there to the pool, from the fence to the pool is 3 meters. This whole distance here is 5 meters, and that distance is 3. And so we came up with 11 meters. But that was the diameter. And folk, we don't need the diameter for this. We need the radius. And the radius is half the diameter. So if my diameter is 11 meters, my radius must be 5.5. So we're going to say times 5,5 meters. But, importantly, and folk, I mark questions at the end of the year in your final papers, and I get so frustrated because so many students forget that it's not just the radius we need, but it's radius squared. You can't believe how many people forget to square the radius. So let's do that straight away. We're going to say squared. Can you see here? We've got to square it. Let's square it. Right, let's put this in our calculator. So I have 5.5 times 5.5, because it's squared, equals, and I'm going to get an answer here of 30,25. So we're going to say, right, that is times 30,25 meters squared. We still got to multiply it by the 3,14. So that answer we're going to times by 3.14, and we get an answer, and there it is, and we're just going to change it to a decimal, 94,985. So 94,985. 985 what? Meters squared. So that's the area now of the whole pooled area, or the whole fenced area, including the pool. Now let's just find what is the area of the pool. So again, we're going to use the formula, and I'm going to write it right next door. Area equals pi 3,14 times the radius of the pool. So let's just see, what is the radius of the pool? Well, the diameter of the pool is 5 meters, so the radius must be half that, which is 2.5 meters. So we're going to times 2,5 meters, but again, folk, squared, because radius squared, equals, so I have 3,14 multiplied by, let's take our calculator, and let's go 2.5 multiplied by 2.5 meters equals, and we're going to land up then with 6,25 meters squared. So equals 6,25 meters squared. We haven't finished. We still got to multiply it by 3,14. So again, on our calculator, there's our answer, times 3.14 equals, and my answer is going to land up being 19,625. So 19,625 meters squared. But now we have two different areas. The area of the whole pooled area, including the pool, and then the area of just the pool. Now, if we take the whole area minus the pool, we're going to be left with the area that needs to be grassed. And that's the part that's important to us. So I'm now going to say the area of grass, okay, equals this 94,985 meters squared minus the 19,625 meters squared equals, on our calculator, 94, let's clear that, 94.985 minus the 19.625 equals, and my answer then is going to be 75,36. So let's write that down straight away, 75,36 meters squared. So that's the area that needs to be grassed. But we haven't finalized the question. The question says, how much is this going to cost me? Now, we know the cost of one tray. And we know that that one tray covers 4 meters squared. So how many trays do we need? Well, let's just clarify that. The question says one tray covers 4 meters squared. So we've got this area. Let's say the number of trays, okay, number of trays is going to be the 75,36 meters squared, and let's divide it by 4 meters squared. So we know how many trays we need. So I've got 75,36. I'm going to divide it now by 4, and I get an answer now of 18,84. So 18,84 trays. Now, here's an important concept. You cannot buy 0.84 of a tray. People get annoyed if you walk into their shop, okay, and say, "Oi, I don't need this whole bag. I only need part of it. So let me rip the bag open, take what I need, and leave the rest on the shelf." You're going to have a very angry shopkeeper. And it's the same with this. The same principle applies. We go off to a shop and it sells grass in trays. I say, "Oi, I need 18.84 trays." The shopkeeper's going to say, "I don't sell part of a tray. You buy the whole thing or you don't buy any part of it." So now the question arises, do I buy 18 trays or do I buy 19 trays? Well, folk, if I buy 18 trays, I'm not going to have enough grass. There's going to be a little patch left over. So I have to buy 19 trays. I'm not going to use all 19, but I still got to buy it. So I'm now going to say, although I need 18.84 trays, no, I need 19 trays. Now, how much is this going to cost me? So down we go again, and we're going to say, right, the cost is 19 trays times, how much was each tray? Each tray, 89 Rand 95. So 89 Rand 95 cents. Back to our calculator. We're saying 19 trays is what I have to buy. Each one cost me 89 Rand and 95 cents. Equals, there's my answer right over there, 1,709 Rand. So 1,709 Rand and 5 cents. That's how much money I need to plant grass around my pool. Sure, that was a tough question. And it was, but it was simple if we followed through the basic steps, remembering always to use the formula that was given. Now, I know we said we're busy looking at a paper one, and I have a confession to make. This kind of question would never be in a paper one, but it would be in a paper two. Definitely, you could find a question like this. But I thought, because we had a lovely question, let's extend it and let's make use of this question. And that's why I made it a little more difficult than what it was in your paper last year. Okay, we haven't finished the question. There's another part to it. And the next part says this: the kiddies' pool is filled with 6,000 liters of water. Mrs. Smith wanted to know what this volume of water would be in gallons. Convert the volume of water in the pool into gallons if 1 gallon equals 4,546 liters of water. Now, here's an exciting thing. If you look at the mark allocation, you will see it's only allocated 2 marks. That means, folk, we're not going to spend hours doing the question as was the case in the previous question. It's going to be a short little answer, okay? Little bit of working and pow, the final answer. So let's go for it. So we want to know how many gallons. There's 6,000 liters. We have 6,000 liters. Now, what is more, a gallon or a liter? 1 gallon, 4,546 liters. In other words, there are a lot of liters in 1 gallon. So a gallon is bigger. So we've got 6,000 liters. If I divide that now by 4,546 liters, I will know how many gallons I have. Again, with our calculator, we've got 6,000 divided by 4.5, let's just see, 6,546 equals, and there we get it. It is 1,319.84, okay? So we're going to say I have 1,319.84. Happy? And that's the end of question 3. Right, let's have a look at question 4. Question 4 is adapted from your November 2010, paper 1 last year, and it was initially question 5.1, but I'm calling it question 4 for today's session. And the question reads as follows. Mr. J. Kozo owns a plot, as shown in the diagram below, not drawn to scale. Now, I want to draw your attention to this, please. Not drawn to scale. In other words, if you see a distance that long and another distance that long, just because this looks half that distance, you can't say because they tell me this is 2, I'm going to presume that's 4. Okay? You may not do that because the question tells you the diagram has not been drawn to scale. So his house, D, is on the eastern side of the plot. Also on the plot is a cattle kraal, a circular water tank, and a vegetable garden. So let's have a look at all this. Okay? Here's his plot of land, this whole area over there. Okay? A is his cattle kraal, B is the water tank, C is a vegetable garden, and D is his house. Got the idea? Now that we understand the diagram, let's look at some of the questions. Okay? In fact, before we look at the questions, there's a whole lot of dimensions that are given to us, but we'll worry about that when we need them. So there's our diagram. Let's look at the very first question. Give the general direction for the water tank from the house. Now, we haven't looked at this yet, but let's just stop for a minute or two and look at our different directions. We know that we have north, we have south. We also know we have west and we have east. And remember, west-east should spell the word we. So you can't have east this side, otherwise you're going to have a word EW, okay, which is you, which there's no such word. So it's we, W, and then the E. North, south, west, east. We have another direction over here, which is between my north and between my east. So I'm going to call it northeast. That makes sense. I have another direction here, which is between my south and between my east. And I'm going to call it southeast. Another direction over here called northwest, and another direction over here called southwest. Now we want to know, give the general direction for the water tank from the house. So let's look at our diagram again. Here's my house, here's the water tank. I'm looking in this direction. What is this direction? Let's have a look. This direction is southwest. So my answer is going to be in a southwesterly direction. Happy? Straightforward, and it was only worth 1 mark. So I knew there wasn't a lot of work involved. In fact, I knew chances are I just needed to give a 1-worded answer or a 2-little-worded answer. And my answer, southwest. Next question. Determine the perimeter of Mr. Kozo's plot. So, finding the perimeter of this plot, we want to now say, if I were to stand on one spot of his land, okay, on the outside of his land, on one spot, and if I were to walk right around his land, how far would I have to walk? Well, let's have a look at it. I'm starting, if I were to start in this spot over here, to walk from this spot all the way to that corner, I'm going to walk 250 meters. To walk from that corner to that corner, 200 meters. From this corner to that point, 150, a further 200, and then finally another 224 meters. So what is my answer? My answer is quite simply, determine the perimeter. Perimeter equals the 250 meters plus, let's have a look at the diagram again, plus the 200, plus the 150, plus the 200. So we're going to say plus the 200 meters, plus the 150 meters, and plus 200 meters. Plus, there's one more distance, and that's this distance over here, which is 224 meters. So let's find it, plus 224 meters. Okay. Equals, and now all we do is we take our calculator, and we are going to say the following. Okay, we're going to say, right, I am saying 250 plus my 200 plus my 150 plus another 200 plus 224. And my final answer is going to be 1,024 meters. So it's 1,024, what's the unit? Meters. Is it meters squared? No, because meters squared belongs to area. Is it meters cubed? No, because cube belongs to volume. It's just the unit by itself because we're dealing with perimeter. So it's meters. So the final answer there, 1,024 meters. Straightforward, simple stuff. Next one, question 4.3. Calculate the volume of water in the circular water tank, if the height of the water in the tank is 2 meters. Use the formula, volume equals pi times r squared times h. So we are now going to put this over here. I'm going to say, and let's just extend this, volume equals pi times, what was it? Let's have a look. Times r squared times my height. Okay? Times r squared times my height. Now, what is pi? Well, the question says we've got to use pi as 3,14. What's the radius of my tank? So now what I'm going to do is I'm going to jump back here, because in the initial question, there was a whole lot of information given. We were told information about the cattle kraal, where we were told the height, the base, the slanting side. We were told about the water tank, where the radius is 10 meters. We were told some information about the vegetable garden. And we were told some information about the house. Right now, I don't want to know any of that information except about the water tank, because this question's about the water tank. And it states quite clearly my water tank has a radius of 10 meters. So let's go find this. Here it is. What's my radius? 10 meters. Not just 10 meters, but 10 meters squared. Remember in the previous question, I said to you, so many students forget to square the radius. Guys, if the equation says r squared, it just makes sense to square the radius. Don't make that careless mistake at the end of the year. Check your formula and check that you're filling in the correct values, and where you've got to square, you square that value. Right, back to this question though. Times the height. Now, what was the height of the actual water tank? We were told the water in the tank was 2 meters. Let's just clarify that quickly. Here we go. In the tank is 2 meters. So that's what we're doing. So back to here, we're going to say, right, times a height of 2 meters equals 3,14 multiplied by 10 squared is 100 meters squared times, let's just write that again, times my height of 2 meters equals, my calculator comes out, and we're going to say 3.14 multiplied by 100 multiplied by the height of 2 meters equals, and there's our answer, 628. So I've got 628. 628 what? Meters? Meters squared or meters cubed? Volume meters cubed. So the volume of that tank is 628 meters cubed. Happy? Of course we are. And we're happy because we did two important things. The first thing, we used the formula that was given to us. And secondly, we ended with the correct unit. Right, let's have a look at our next question. Now, our next question, question 4.4. Determine the area of the cattle kraal. Use the formula, area of a triangle is half the base times the height. So let's do this quickly. I'm going to rub that out so we've got some space to do the next question. And what we're going to do now is we are going to try and calculate the area of the cattle kraal. Please take note, this is our cattle kraal here, area A. What is the shape of it? A triangle. And that's why they've given us the formula for the area of a triangle. It would be silly if they gave us the area of a circle or the area of a rectangle when the kraal is in the shape of a triangle. Area of a triangle equals half times the base times the perpendicular height equals. Now, we've got to go right back. In fact, we don't even have to. We can just look at this diagram. Firstly, a half is a half. We're going to write a half. The base. How long is the base of this triangle? We can see it there. It's 200 meters times. Now, an important concept. How high is this triangle? Right. So I have a son. He's 8 years old. His name is David John. And he takes me up to about this high, okay? So he's just under my elbow, around about my elbow height. Who's taller, me or him? Obviously, I'm taller. However, if I had to lie down, who would be taller, him or me? Well, now that's a difficult question. I'm still the tallest person. But I can't look at which is taller if one is at an angle and the other one's standing up straight. Okay? So let's have a look at this triangle. Here we have two heights we could use. We've got a height of 224, or we've got a height of 200. How high is this triangle? Folk, the triangle is not that high. It's that high. It's my perpendicular height. So it's the height from the base to the very top of that triangle. Okay? So how high is this distance? That's what we want to know. And this distance is the same height as there. It's 200 meters. That is not my height, folk. That is my slant height. But it's not the real height. So if I were to build a building and I built it all skew, and instead of building it straight up, it somehow became the leaning tower of Pisa. Okay, so here I've got a leaning tower. How high is that tower? The height is not the leaning height, but our height is from the bottom of the ground to the very tip. So even though it's leaning, that's not the height. And that's an important concept we've got to understand. Because again, that's a mistake so many matrics make in their final paper. So our height, 200 meters. So we know now the height is 200. So base 200, height is a 200. Going off now to our calculator, and we're going to say, right, I have a half, or 0.5, multiplied by 200, multiplied again by 200 equals, and its answer 20,000. So I have an answer of 20,000. 20,000 what? Well, it can't be meters because I'm not finding the perimeter. It can't be meters cubed because I'm not finding the volume. It has to be meters squared, area squared. So 20,000 meters squared. How great is that? Okay? Straightforward, basic, good stuff. Remembering, follow the equation, and remember the correct units. Right, let's have a look at the next question. In fact, it's the final question from question 4. Calculate the total area of Mr. Cause's plot. Use the formula. The area of a trapezium is half the sum of the parallel sides times the height. Let's go here. I want us to look at this diagram. Please understand this. This whole diagram is actually in the shape of a trapezium. Now, what is a trapezium? A trapezium is when we have two parallel sides, okay, two lines running parallel, and the other two sides of the shape don't have to be parallel at all. As long as I've got two parallel sides, I'm going to land up with the shape being a trapezium. And if we look at the shape, we can see here that I'm told it's a trapezium because the question says use the following formula, the area of a trapezium. So in other words, here's the one parallel side, here's the other parallel side, and this is the distance between the parallel sides. Again, this 224 is not the distance between those sides. This is the distance, 200 meters. So let's go and have a look here. Okay, right, that was a previous question. That's gone. That was simple. That was easy. We got the next challenge. And the challenge is that our area of our trapezium is half times the sum of the parallel sides. What's sum mean? Sum means plus. Okay, difference minus, product times, okay, and quotient divide. Sum plus. So it's half times the sum of the parallel sides, okay, times the height. Now, what are my parallel sides? Well, the one is 250 meters, so I've got 250 meters. How long is the other side? Well, it's 200 meters up to this point, plus another 150. So it's 200, 350 meters. Times my height, which is 200 meters. There it is. So I've got a half times 250 plus 350 is going to give me 600 meters times 200 meters. So let's do this on our calculator straight away, and we're going to say, right, I have a half, 0.5, times my 600 meters times my 200 meters equals, and there's my answer, 60,000. Now, again, we're going to ask ourselves, 60,000 what? Can't be meters, we're not dealing with perimeter. Can't be meters cubed, we're not dealing with volume. It has to be squared because we're dealing with area. So my answer is 60,000 meters squared. So how big is this plot of land? This plot of land is 60,000 meters squared. And that's the end of question 4. Now it's time to look at question number 5. Question 5. Now question 5 is taken from your November 2010, but it's taken from paper 2. In other words, folk, this question is going to require quite a bit of thought, and we expect that. Now, with the paper 2, what I want to stress is this, that sometimes you're given a whole lot of information, and when you read the whole question, you look at it and think, oh my goodness, where do I start? Don't panic. Read the question, get a general feel for it, then look at the individual questions and extract the information that's required just for that question. Otherwise, it can get rather confusing. So let's have a look at this question. So Triggers Enterprises was awarded the tender for making rectangular cardboard boxes to package bottles of cough syrup. Each bottle is packed in a cardboard box with a square base, as shown below. And let's have a look at that straight away. There's the box over there. So we're going to have some cough mixture, and I put in a little picture here showing you a bit of cough mixture, okay, and there's the box. And the box has a little square box, all right, a square base. And that's important to remember, because we might only be given the length of one side, but because we know it's a square, we know the length of the breadth, or the length will equal the breadth. Okay? So moving on now. The diameter of the base of the bottle is 58 millimeters, and the height of the box is 143 millimeters. Can I draw this on here? So we're going to say, right, my bottle has a diameter of 58 millimeters. So over here, I have 58 millimeters, right? The next bit of information that's given to me is that the height of the box is 143 millimeters. So my height of the box is 143. Now, it's important to understand that it's very easy to get confused as to whether the examiner is talking about the box or the bottle. So we've got to read the question carefully. We're told the diameter of the bottle is 58 millimeters, and the height of the box is 143 millimeters. Right, next bit of information. The length of the side of the box must be approximately 105% of the diameter of the bottle. So this box must be 105% of 58. Next fact. The height of the box is approximately 102% of the height of the bottle. So the height of the box is 102% of the bottle. Okay? Happy? Let's get on to a few questions. Oh yeah, and they give us a whole whack of formulas. The first formula they tell us is area of a circle is pi r squared. Folk, we're going to use that. We have to, because the examiner's given it to us. The area of a square is the side of the length squared. We're going to use it. We have to. The examiner gave it to us. And the area of a rectangle is length times breadth. Again, we're going to have to use it. Why? The examiner has given it to us. Now, the following conversions may be useful. 1 centimeter squared is 100 millimeters squared, and 1 meter squared is 10,000 centimeters squared. Sure, all of this question, we haven't even got to question, or the first part of the question, and we've just been bombarded with information. Okay? Let's look at the questions individually and pick out the information we need for that question. So, my first question says this. Calculate the height of the bottle to the nearest millimeter. So, the height of the bottle, we know the height of the bottle is, or that package is 102% of the actual bottle. So what is smaller, the bottle or the box? Folk, obviously the bottle must be smaller. It's got to fit inside the box, okay? And it's 102%, the box is 102% of the height of the bottle. So how do we do this? We are going to say then, the bottle, the height of the bottle, okay? The height of the box we know is, where is it? 143 millimeters. So I've got 143 millimeters. Now, we're trying to find the height of the bottle. I can do one of two things. And I'm going to put both down and we're going to see which makes more sense. I can say 100 divided by 102 or 102 divided by 100. The bottle must be smaller. So what is going to make my 143 smaller? Multiplying by 100 and dividing by 102, or multiplying by 102 and dividing by 100? Obviously, to make something smaller, we've got to divide by the bigger number. So if I look at this, which is the bigger? That. So this is wrong. So I'm going to say the height of my bottle is 143 times 102%. But because I want it smaller, I'm going to put the 100 on top, the 102 at the bottom. So let's have a look at it. We're going to say, right, I have 143. I'm going to multiply it by 100. and I'm going to divide that answer by 102. Okay? And what's my answer? My answer works out to being 140,19 millimeters, or 140,196. So 140,196 something millimeters. But the question says to the nearest millimeter. So what, I got 140 or 141. What am I going to choose? 140, 141? Well, 0.1 means it's closer to 140 millimeters. So I've now worked out the height of my bottle. So if I go back to the diagram, I'm going to say, right, the height of this bottle is actually 140 millimeters. Happy? Easy. And please take note as well that this question was for 3 marks. Okay, 3 marks. So we knew there wasn't that much work. There was a bit of work involved, but it wasn't a whole page long because it was only 3 marks. If, however, we look at my next question, I'm not going to read the question. Let's just look at this. 11 marks, folk. 11 marks for this question. That means I've got a whack of work waiting for me. So now we need to get down and actually tackle it. So in order to minimize the cost of cardboard required for the box, the following guideline is used. The difference between the areas of base of the cardboard box and the base of the bottle should not be more than 11 centimeters squared. Determine whether the dimensions of this cardboard box satisfy the above guideline. Show all appropriate working. Please take note, they've actually enlarged the word all. In other words, you have got to show your working. If you don't show your working, folk, you are going to lose out on so many marks. If I get my final answer wrong, okay, but I've shown clearly, shown the examiner, shown the marker, this is how I did this, and that's how I got that answer. This is how I did this part and got that answer. This is how I did this part and got that answer. And although I may have messed up in one of the parts, I'm still going to get the marks for the other parts. But if I don't show all that working, how can the marker give me the marks? He can't see what I've done. So I'm going to show the examiner exactly what I'm thinking. Let's talk about this question. So we told that the difference between the areas of the base of the box and the base of the bottle. So the box has got a little square base and then the bottle around base. The difference between those areas can't be more than 11 centimeters squared, right? Let's see if this is the case. First thing I'm going to have to do is find the area of the box. So let's go for it. So I'm going to say this. The area of the box, okay, is going to equal, now remember, it's a rectangular box, so it's, square box, so it's going to be, the length and the breadth are the same. So my formula is length squared. And if we go right back to that first page here, you were given that the area of a squared is the length squared. So yes, sir, thank you very much. We're using that formula. So back here, length squared. Now, what is the length of the box? Let's find it over here. Oops, we're just trying to find this box quickly. Here it is. It is, we got a problem. And our problem is we're not told how long that box is. But what we are told is it has to be 105% of the diameter of the bottle. And the bottle is 58 millimeters. So the length, we are going to say we've got 58 millimeters. And the box is 105%. So the box, 105 over 100. Remember in the other one, we put the 100 on top, and we did that because we wanted a smaller answer. but we know that the box has got to be greater than the bottle. So we want the bigger number on top. So we're going to put 105 on top, divided by 100. And now all we're going to do now is with our calculator say, right, I want 58 millimeters, multiply that by 105, divide it by 100, and my length is going to land up being 60,9. So I've got a length then of 60,9 millimeters. So 60,9 millimeters, but we've got to square it. Why do we have to square it? Because the formula tells us length squared. Calculator comes up again, and we say 60,9 multiplied by 60.9, and we land up with this answer of 3,708. Let's put it down there. 3,708,81 millimeters squared. Why squared? We're finding the area of the box. Okay, so we found the area of the box. Now we just need to find the area of the bottle, in the base of the bottle. And we know that the area of the bottle, because it's round, is going to be pi times r squared. Let's go all the way back here to the initial question, which said area of a circle, pi times r squared. Thank you, examiner. I'm using that. And please take note, pi's got to be 3,14. Can you see how I'm ticking off the formulas as I use them? Because I know by the time I'm finished that whole question, I have to have used all those formulas. Otherwise, I could have a problem. Right, back to our question. Now, pi times. Now, the radius of the bottle. If we go back and we look at the radius of the bottle, remember, we said the diameter of the bottle is 58. Quick recap. Diameter means 2 radiuses. So if I have a diameter of 58, what's my radius? Must be half of 58, which is, we'll make it 29. Okay, so we're going to go back here, and we're going to find the 29 times 29 millimeters. Remember, please, square it. Okay? So calculator comes up, and instead of pi, we're going to say 3.14, because that's what the examiner wants, times 29, and times 29 again, because it's r squared, equals, and there's my answer over there. It's going to be 2,640,74. Okay, so 2,640,74 millimeters. Millimeters squared, because it's area. Now, folk, we haven't finished, eh? Because what we now have to do is we have to find the difference between those areas. So let's take the area of the box, and if you look here, the area of our box was 3,708,81 millimeters squared, minus the area of the bottle, which is 2,640,74 millimeters squared. And we're going to subtract those two. So calculator comes up again, and we're going to say, right, let's clear all that. And we're going to say the 3,708.81 minus the 2,640, there it is, 0.74 equals, and we're going to land up here with an answer of 1,068,07 millimeters. So 1,068,07 millimeters squared. Right. Sure, we're coming closer to the end of the question. It's been a lot of work so far, but we were expecting that because it's for 11 marks. And we've now worked out the area, and the area is now 1,068,07 millimeters squared. But we've got a problem here. Let's look at the question again. The question said this. the difference should not be more than 11 centimeters squared. And my answer is in millimeters squared. So somehow I've got to change that millimeter squared to centimeters squared. And how am I going to do it? Let's go right back to the very first question when they gave us all that information. Look over here. The following conversions may be used. I always smile when I read that may be used because I know the examiner's actually saying, "Oi, it must be used, so use it." And this is what we're using over here. 1 centimeter squared is equal to 100 millimeters squared. So let's look at my answer. My answer over here of 1068,07 millimeters squared. To change it to millimeters squared, we're going to divide it by 100. Okay? In dividing that by 100, our answer is going to be 10,6807 centimeters squared. Now you may ask, "Hey, how many decimal places do we have to round this to?" Well, this is one of those questions where it really doesn't matter. Why? Because all we want to know is this: is my answer bigger or is it smaller than 11? And my whole answer of 10,6807 centimeters squared is smaller than 11. And because it's smaller than 11, when we look at the question said this. No, that wasn't the question. Here's the question over here. It said, determine whether the dimensions of this cardboard box satisfy the guideline. In other words, is it smaller than 11? Yes, sir, it is definitely smaller than 11. So I must end off by saying, therefore, it does satisfy. The requirements. Okay? Got to end with that. You got to tell the examiner that because that was the question. Does it? Yes, it does. Folk, I trust you've had a great time. You've learned a lot. If I had to recap everything we've done so far, I would say this. Please remember, number one, most importantly, always use the formula the examiner's given you. Okay? Secondly, always end off with the correct units. You've got to do that. And remembering, if it's perimeter, I'm working with millimeters, centimeters, meters, or kilometers. If it's area, I've got to put a little 2 above those units. In other words, millimeters squared, centimeters squared, meters squared, or kilometers squared. And if it's volume, cubed. Millimeter cubed, centimeter cubed, meter cubed, or kilometer cubed. Please remember, end off with the correct units. Start by using the correct formula. I trust we've learned a lot today. Thanks for joining me, and hopefully we'll be in touch soon.